Hello, this is John Rinaldi from Real Time Automation. Today I'm going to talk about a topic that recently I've been talking a lot about on LinkedIn. If you follow me on LinkedIn, you maybe have seen some of this stuff. And this is about UNS. What's UNS? The Unified Namespace. So what is this? Is this another protocol? No, it's not a protocol. It's not a technology. It's a framework for doing things. And the advantage of this framework for doing things is it provides you with consistency across a whole corporation. So I'm going to tell you what UNS is. And at the end, I'm going to tell you where it all falls apart, which has not enamored me to some of the people that really love UNS. So the first thing to know about UNS is that it's not a technology. So let's put that up there. So what do we mean by that? It's a way of what happens is it's essentially collect, model, store, publish data in a standard format into a repository so that everybody else then can take data out of that repository and use it in a standard way without having any trouble. So the second thing about UNS is this central repository. So all the data goes into the central repository and it can be easily accessed by the quality people can get at it, the accounting people can get at it, the operations team can look at the data. All these people who want data from the machine can get it from the repository in a standard way. Another thing about this in the framework is that data is constantly streaming from the machine. So let's put the machine here. And then the data is constantly collected, streaming into this framework and being collected. How's the details of how it does this, how you implement this. There's 100 different ways of implementing this. There's 100 different examples of this. I'm going over it just from the 50,000 foot scale, that this is just a simple way to explain what the whole thing is. Another thing that has to be part of this is the taxonomy has to be the same. There's a good fancy word. I don't really use these fancy words much, but the taxonomy, that means that these things are all named properly. So if you have a speed here, if you have a thing like here, if you have a speed, you have a pressure, let's say you have air pressure, you have a count, a cycle count. You could have, there's all kinds of things, but the idea is all of these things are named properly so that when the operations people want to know what is a machine 20, what is the cycle count, they know that what the name of the tag is, and they know the fact that that machine 20, that's the ASCII name they expect. The cycle count is integer 16, so 16-bit unsigned integer, for example. So all this stuff is predefined so that there's no problem with getting data but not knowing what it is. Because if you get like this, then, that could mean 28 degrees, it could be 28 cycles, it could be 2.8. You have no idea what that 28 might refer to. So when you collect this stuff, it is collected in what is normalized into a standard way. And then after it's normalized, it gets metadata attached to it so that these people can understand exactly what they have when they go to extract the data out of there. This stuff is pushed out on the edge by publish subscribe architecture. That's usually MQTT, but OPC UA has a pub sub associated with it too. But typically the people who are doing UNS are all talking about MQTT. Running out our little room here. So it's also event-driven. Event-driven means that when something happens, then the data gets pushed out based upon whatever that event is. There's no silos in this kind of framework, meaning that there's no specific piece of data that you can't get. Everything ends up in this CR, the central repository. There's no silos. The data is hierarchically organized, so that means it could be something like 8 is hierarchy. So you could have plant, something like, and this is defined by the individual corporation. So it could be anything: plant, machine, cell, line, and then it could be device, and then a tag underneath that. So you have a definite hierarchy to all the data in here, so that these things can drill down as deep as they want to get the data. This is all the other thing about the framework is it's scalable. If you do this right, you can use this on one small area of your plant, or you could use it on the whole corporation and all 40 plants that you have. And then the last thing about the framework is that it serves as a foundation for all the kinds of things that we want to do, which is AI and machine learning and analytics and all that kind of stuff. There's a lot of talk now about predictive analytics, of course. Everybody's been working on predictive analytics forever, but until you have this, you have this central repository, it's really hard to do predictive analytics. And the thing about this, to do predictive analytics, you need to actually have really detailed data. Okay, so let's talk. So this is really great. What's wrong with it, John? Well, let's talk about. Here's the thing. The part of this that frustrates me is that if you're talking about I'm talking about a larger organization, like a big Fortune 50 kind of manufacturer that maybe has 50 plants, 100 plants, maybe even 2 plants. If you have that kind of an organization, getting all of the data organized such that to have that we're all using the same models, that we've all decided on it, because when I talk about this central repository, there's all different users for this, okay? There's as I said, there's the quality teams, the operation teams, the business teams, analytics teams. There's people who are doing AI. Getting everybody to agree on what the taxonomy is, what all these names are, and to agree on what the models should look like, I think is really difficult. It really takes a hero that knows how to do all this and can really push it through, that has some kind of clout that can push this through the organization and overcome objections, because it's really hard to satisfy everybody. But what you want to shoot for is you really want to just try to can we satisfy 80% of the users who are going to use all this data? And but the whole thing falls apart. The real difficult part is doing this taxonomy in these models. And that's where I see that, I don't see that it's hard to overcome in big corporations, because they move very slowly, and people in different parts of the organization don't always like to work together. It's not just IT and OT. There's different, every little department has their own thing, and they would like to protect it. They do, the quality people, they do things their way right now. Do they want to work with the operations people and come up with a standard model that can be that both of them can use? Really hard to get these people to cooperate on that, because people resist change. That's what we are. We're humans. We like the things we're doing now. It's really difficult to get us to do something else. So in summary, UNS is really a really interesting framework. It's got a lot of capabilities. There's a lot of great structure there. There's been a lot of terrific work done on it. I just want to see this data modeling, the taxonomy issue, a way to solve that in a way that's going to make sense for people and make it easier for people in big corporations to roll this out. My name's John Rinaldi. Happy to talk to you today. I look forward to talking to you in the next video.